are presenting our project, Hazop analysis in mechanical lab, which is Fabrication laboratory. Our introduction is Hazop is an acronym created by combining the words for hazard and operability. It is primarily used to study complex operational hazards and function in chemical processing plants, but it also used in nuclear, water, sewage treatment plants, oil and gas. A hazard study is performed by an interdisciplinary teams for aspects including engineers, chemists, facilities managers, and safety officers to identify procedural risks, processes hazard, and design flows.
We proceed to the problem statement, which is the first point is every industry in Malaysia had the machine or any equipment that may be hazard. The second one is the probability the hazard of a machine can cause explosion, burning, electric shock, and many more. It can cause many workers in life-threatening. And the fourth one is the industries want to save the budget with not appoint a worker who specialize in safety of machines. And last one, several of the industry not had a process design or its operation of the process safety or unit operability. So in this project, our objective is to identify the hazard of machine or equipment in any fabrication lab. And then the second one is to identify potential hazards in the system. And last one, not forget, is to identify potential operability problems and the causes of operational disturbance with the system. For the hazard matrices, hazard matrix is actually essentially similar to the matrix applied in a failure mode effects analysis without the inclusion of probability, severity, and detectability. The first one is the process parameter under analysis. The second one is the potential hazard. The third is the potential failures associated with the hazard. The fourth one, potential cause or causes of the failure. And the last one is the details of the causes of the failure. Next, we present the hazard matrices. So we observe the critical analysis, and the first hazard that we found is the dust or powder in the lab. This can cause the potential risk that lead to eye tissue, and the second one is rubbing can cause abrasion of cornea, and the third one is irritation the skin and may produce skin abrasion. So for the existing control, we must wear safety glasses with side shields and use previously glove to protect your skin. And third one is rinse immediately with plenty of water. So the likelihood is 2 and severity is 4, and the total for the risk is 8 according to the hazard matrices. So recommended control measure is, in case of contact with eyes, seek medical advice as soon as possible and keep material in a good area, storage procedures, and that's all. And the next work activity is the thermal process, which is the hazard is hazardous combustion products. So the potential risk that may lead is respiratory dermatitis and skin lesions. So the existing control that we may take is wash immediately with soap and water, and then cuts or abrasions should be treated properly. So the likelihood is 2 and the severity is 5, so the risk is 10. The recommended control measures that we can take is prevent release to air, sinks and drains, sewers or water runoff. Then appropriate NIOSH or Malaysia approved respiratory protection must be provided there. Work activity is the hot stuff in the pipeline. So the hazard is flammability properties leak out. So the potential risk is that respiratory dermatitis and skin lesion also. And then the existing control that we might use is keep product damp to minimize fire hazards. So the likelihood is 3 and the severity is 5. So the risk is 15, which is danger for you. And so the recommended control measure that we can take is containment procedure by prevent release to air, sink, drains and sewers. Another work activity, but this is the last one, which is the melting process. And the work activity is direct current, and the hazard is fire and burn hazard. So the potential risk is that that this can cause respiratory problems, and what the existing control that we may take is avoid inhaling any combustion products. So the likelihood is 5 and the severity is 4, so the risk is 20, which is so danger. And lastly, that recommended control measure that we can take is firefighting equipment must be there over there, and firefighters should wear breathing apparatus, protective clothing. Here is a few recommendations for you to reduce any hazard in the lab. So for the steam explosion, make sure your delivered materials are free from moisture and stored in a dry place. And second one is furnaces and refractories are preheat before use. And the last one, we must use bottles and container holding liquid, and sealed or pressurized cans are not taken into molten metal areas. And second one, if for the heat stress, eliminate unnecessary heat and water vapor sources. Second one, installing spot coolers, blowers, fans or aircon to relieve humidity and move the air. Third one is we must supply clean fresh water, and lastly we can provide task specific PPE, for example water cool clothing or heat reflective clothing. And lastly, for the physical hazard, label hazardous chemical correctly, and then store incompatible chemicals well apart, and then ensuring floor surface material resist damage from the foundry process. And last, designing or rearrange foundry layout around workflow to avoid slips, trips and falls. For the conclusion, that for this project is research laboratory present many challenge in the day-to-day bustle of conducting research experiments. Worker health and safety can be easily overlooked. However, with proper guidance, a trained eye and practice in noticing the mundane, we can find and correct many common mistakes and prevent illness or injury. That's all from us. Thank you.